Hello everyone, my name is Binhui. I'm a PhD student at Beijing Institute of Technology, and this is a record talk for our CVPR paper towards fewer annotations, active learning via region impurity, and prediction uncertainty for domain-adaptive semantic segmentation. The fundamental assumption in supervised learning is that we have the same distribution for training and testing, denoted as P and Q respectively. However, this is almost impossible in the wild. P and Q are different, and we see there are distribution shifts. For example, many outdoor applications, such as autonomous cars, are required to operate smoothly in the conditions of bad weather. The aim of our work is to promote research into the design of adapting deep models to new domains. Unsupervised domain adaptation is a popular way to transfer knowledge from a labeled source domain to an unlabeled target domain. However, UDA performance still lags far behind the supervised counterparts. In practice, it's feasible to get some target data labeled, which has been widely studied in active learning. In our work, we focus on the less studied problem, active domain adaptation. Specifically, we adapt a trained source model to a related target domain given the ability to acquire annotations for a fixed budget of target data. The key challenges consist in effectively using limited target annotations and operating under domain shifts. We found that existing paradigms using image-based or point-based selection strategies are less effective. Particularly, image-based selection will sample redundant errors within objects, while point-based selection is prone to sample pixels that come from specific categories. Our primary contribution is a simple and effective region-based acquisition strategy, which is tailored for the semantic segmentation. The framework of our method is shown in the picture. The first step is to pre-train the model on labeled source data, and then query informative regions or pixels in the target image for labeling. Finally, retrain the model with available data. At first, we consider k-squared neighbors of a pixel as a region. Compared with traditional active learning methods using superpixels and fixed rectangles, our k-squared neighbors are more flexible. Given the predefined regions, next, we divided a region into C subsets with target pseudo-labels, and propose a novel region-based selection, region impurity, to assess the significance of regions. Then, we employ the predictive entropy of each pixel, and average all entropies within the region to evaluate the prediction uncertainty of each region. Combining both region impurity and prediction uncertainty, we can obtain the acquisition score. Then, we select a batch of samples to annotate and repeat this process until the labeling budget is exhausted. Our training objective including two supervised losses, a consistent regularization, and a negative learning loss. We present experiments for semantic segmentation on two popular sim-to-real adaptation tasks. With very few annotations, our method almost reaches the supervised performance and substantially outperforms state-of-the-art methods. For another task, our method also consistently outperforms previous works. As shown in the blue box, our method even surpasses the supervised performance in specific classes. We also visualize the selected regions and observe that uncertainty only turns to lump regions that are nearby together, while impurity only focuses on regions that include as many as categories. Last but not least, we also extend our method to source-free DA and obtain considerable improvements. Thank you for listening. For more details, please visit the original paper and open sourced code.